Hello guys, in this video we're doing a galvanic cell. So I want to see what is a galvanic cell in detail. Okay, a galvanic cell is an electrochemical cell which has two compartments. These two compartments with a salt bridge connecting these two compartments. So we have, this is the salt bridge. This is an electrode. So this one is not specifically labeled whether it is the positive one or the negative one. So let's just mark electrode A and electrode B. Then this is electrolyte. This side is also electrolyte. Then this one, it's a voltmeter. It can be a voltmeter or any device that consumes current or voltage. So let's see the processes that takes place internal the galvanic cell. So there is conversion of energy, or energy conversion is chemical energy converted to electrical energy. So we have this salt bridge that I have marked in. So I want to see what are the uses of salt bridge. So salt bridge, it balances the electrical neutrality in the inside the cell, or it completes the circuit. It also balances, or let's say it maintains. It also maintains electrical neutrality. Inside the cell. So the types of reactions that take place inside this galvanic cell, they are called redox reactions. So let me just explain what redox reaction means. It's reduction and oxidation reactions taking place simultaneously. So in this case, chemicals are being put into these compartments. Then as these chemicals are being connected by a salt bridge which completes the circuit, then the chemical reactions start to, or the chemical reactions commences producing current, because there will be flow of electrons from these electrodes passing through the salt bridge. So let's see the movement of electrons in a galvanic cell. So electrons, or before going to electrons, let's see the electrodes first. The anode is negative. This is for galvanic cells. The anode is negative and the cathode is positive. Then redox reactions that takes place in this galvanic cell, they are spontaneous, meaning they can start on its own. We don't need electricity to start up the directions. So in this case, oxidation takes place at anode, reduction at cathode. So the flow of electrons, now let's see the direction of electrons. So electrons flow from anode to cathode through the external circuit. Through the external circuit. Okay, let's have an example. Let's say this is our anode. We say the anode is negative. Let's say electrode B is the negative and electrode A is positive. So the flow of electrons, it will be from anode to cathode, meaning from negative to positive. So the flow of electrons is like this, it takes that direction. That's electron flow. Then from the internal circuit, it is now flowing from here, okay, going this way, then that side. So if the question asks you the flow of electrons in the internal circuit is via the salt bridge. It's from positive electrode to the negative electrode. In this diagram, we are given a galvanic cell with electrodes zinc and copper. Then the type of your electrolyte must contains the ions of an electrode. So in this case, our electrode is zinc, so our electrolyte must have zinc ions, which is zinc sulfate, in order for it to work properly. So in this question, we are being asked to calculate the initial voltage of the cell. To calculate the initial voltage of this cell, we need to go into some few steps that we need to follow in order for us to come up with the initial voltage. So we have what we call the data sheet with the reduction or oxidation potentials with the half reaction of all the metals. So in this case, we have the metals like zinc. So we need to code down those. You got your data sheet, then you code those half equations. So we have zinc 2 plus 2 electron reduced to zinc solid. So this one is aqueous. This is solid. Then you need to copy its cell potential. Its cell potential is equal to minus 0.76. Then we also have copper electrode. So we need to copy for copper 2 plus 2 electrons, we form copper solid. E cell, this is equal to positive 0.34. These are volts. So what we need to do here, we check the one which is more negative. So the half reaction which is more negative is this one. That's the one which reverses, because as you can see, all these half reactions, they are reduction reactions, but this one will be going under redox reaction, meaning it's reduction and oxidation. So all of these metals can be reduced. One need to be oxidized. So the one which is more negative is going to be oxidized. So we need to reverse it. But by reversing this reaction, we also need to reverse its cell potential. So it will reverse to zinc, which is zinc 2 plus 2 electrons. Then it becomes, its E cell will be positive 0.76 volts. So that's first stage. So this stage number 1 is to reverse the more negative half reaction. But now we want to determine which one is the cathode, which one is the anode. Yet we said anode is the negative electrode. So the one which is more negative is the anode. So our anode is the zinc electrode. So this one is the anode. This is the cathode, which is positive. So this is negative, that one is positive. Then after reversing this one, you need to balance electrodes. So now we are working with these two half reactions. This one, we reversed it, so we are no longer using it. So now we need to check if the electrons are balanced. Then our electrons are balanced, 2 electrons, 2 electrons. Then you cancel them out. But if the electrons were not balanced, you were supposed to balance the electrons first, so that the number of electrons transferred in copper should be the number of electrons transferred by what? By zinc. So here, what is on the left hand side, you have to combine species on the left hand side and species on the right hand side on their side. So here, the first species that we can write is zinc plus copper 2 plus. This is solid. This is aqueous, because these are copper ions which are being reduced to copper. Then we form zinc 2 plus aqueous ions plus copper solid. So we have formed zinc 2 ions plus copper solid. So in this case, our E cell, which is the initial voltage of the battery, will be equal to 0.34 plus our reversed voltage, which is 0.34 plus 0.76. We get 1 volt. So 1 volt is the initial voltage of our cell, but we know as this cell operates, chemicals will be used up. This electrolyte. So for you to maintain 1 voltage, you need to keep on continuously adding new chemicals, which is the electrolyte.